The next, I want to discuss a little bit about CAT and sequential analysis. So CAT is a sequential analysis application. Sequential analysis is a very classical statistical method developed many, many years ago. And now we use sequential analysis to help to design adaptive testing. Okay, here I give you a very easy to follow illustration. You see how to design a good test for a specific individual. You see the vertical line, you can consider, it's at a difficult level. The lowest is very easy and then hard, from easy to hard. The horizontal line is a time sequence. Okay, first item to the student, if student answer correctly, the next item should be more difficult, increase the difficulty level. And if a student answer the second item correctly, the next item should be more difficult, right? But the student failed the third item, then we have to decrease the difficulty level. So it's a kind of design, sequential design, the sequence, time sequence. According to the output, according to what we observed, we make our design for the next difficulty. Okay, this design is about the difficulty level. How difficult, how easy. This is something, called sequential design. But sequential design is a very big field. It has had so many applications, such as medicine, drug development, toxicity. When you develop a new drug for a certain disease, and then you need to provide something called a lethal dosage. You need to let doctor know what is the maximum allowed dose, how it is designed. At this dose, patient may die with 50% chance. So this is called a lethal dose. So LD50, lethal dose 50. In medical research, in drug development, people already use this sequential design. And how? You make sequential experiment. You feed animal with a drug. If the animal does not die, you increase the dose. If the animal died, you get new animal, then you decrease dose. Sometimes up, sometimes down, up, down, until you found what you want. So in doing so, you will make the experiment very efficient, means you don't need to kill too many animals. Very efficient. Okay, this is a commonly used method in medical. In computerized adaptive testing, we have what is our observed variable. Observed variable is student's response. If students answer correctly, the response is 1. X are responses. If student answer incorrectly, the value should be 0. And designing point can be, item difficulty level. B is a value. B1 is the first value, the second value. So we try to manipulate the difficulty level according whether we observe the 1 or 0. If the value is 1, we should increase the difficulty level. And then the question is how much more difficult, how much more easier should be governed by a formula so that you can use the computer to program it, right? So this is about give you some general idea, it's a sequential design. You observe the outcome, then you make a design. Then you observe the outcome again, then you make your design again. And that design is like automated. So use algorithm. So it is indeed artificial intelligence. And in our field, Brad Lord, who is a founder of item response theory, he proposed how to measure students most effectively. He said that examinee will be measured most effectively when test items are neither too difficult nor too easy. Okay, what does that mean? If students can answer all the items correctly, actually you receive no information. If the student answer all the items incorrectly, of course, you did not have any information about the student. So we try to make students sometimes answer correctly, sometimes answer incorrectly, then we got information. So Fred Lord was the founder of Computerized Adaptive Testing. He is one of the pioneers who proposed some mechanism, some formulas. And also, of course, the most informative item what is the most informative item? Most informative item, if a student have 50 chance to answer correctly, then we should say this is the most informative items. And also he proposed some formulas. And now we don't need to get details for this formula, just show you, the connection to the equations, to the formulas. So eventually later we'll introduce some formulas and easy to follow formulas. And then how to make an algorithm. Actually, we need to write code. However, this course is literature review. And I taught this course for many, many times in person. And for all times, I will require students to do some projects. But the students are from different backgrounds. How did I manage that? I always group students, divide class into several groups. For each group, make sure one of the students is very good in computer programming. In the future, we can try this, but at this moment, I think this class, gives you thorough understanding about computerized adaptive testing and its potential for the future AI applications.